Hi folks, Dr. K here with today's episode of Science Untangled. Today we do the second part of the balancing equations topic. What to do if you can't see it right away. So we'll start with a redox question here. Don't worry about the redox, that'll come later. But we're reacting hydrogen peroxide with hydrazine to make nitrogen, water, and oxygen. So to start off with, we have a grand total of 6 hydrogens on the left, we have 2 oxygens, and we have 2 nitrogens. Right now on the right, we also have 2 nitrogens, we have 3 oxygens, and we have 2 hydrogens. Okay, now first things first, we're going to need to have an even number of hydrogen peroxide in order to end up with an even number of water molecules. If we don't have that, we're not going to match the oxygens. So we don't have to start with one H2O2. We can start right away with 2. I will try it with 1 N2H4. So what does that change? So now I have a total of 8 hydrogens. I have 4 oxygens here, and I still have 2 nitrogens, okay? So that means I'm making one of these, and based on the oxygens, I should end up with 2 H2O and, well, not 2, like 1 O2, there we go. And as you'll see in a second, that's not quite what we need, because now I have 4 hydrogens and I'm not there yet. Okay, so as I said, we need an even number of H2O2, so let's shuffle that to 4 and see what that changes. So if we make that a 4, I end up with 4 times 2 is 8 plus 4 is 12 hydrogens on the left. I end up with 8 oxygens on the left, all right, and still 2 nitrogens. And on the right, I had 4, I need to get to 12, well, that should get me to 6 water molecules then, right? And that will get me to 12 of these, but 6 O's plus 1 O2 also gets me to 8 O's, and then it's balanced. So it's a combination of counting and considering what ratios you need, okay? Moving on to the second one, a combustion example. So for this one, if I write things down again, we have 2 carbons, we have 7 hydrogens, we have 1 nitrogen, and we have 2 oxygens. And then on the right, we have 1 carbon, we have 2 hydrogens, 2 nitrogens, and we have 3 oxygens, okay? First thing to notice is that on the right you're expected to come up with N2, so you need to have an even number of C2H7N. So let's start with 2 of these. If we start with 2 of these, then we look at the carbons and the hydrogens, so 2 times 2 would get me 4 CO2, 2 times 7 would get me 7 H2O. So where does that leave us? So we end up with 4 carbons over here, we end up with 14 hydrogens over here, 2 nitrogens, which is good. We haven't looked at the oxygen yet. Over here we end up with 4 carbons, and we end up with 14 hydrogens, all good so far. But in terms of oxygens, we end up with 8 plus 7 is 15 oxygens. Okay. 15 oxygens, so that's 7.5 O2, right? So if I put in here 7.5 and I put a 1 here, then technically it's done. So then, final step, as shown before, you need to make sure that you end up with your lowest whole number ratio. So the numbers here are actually getting reasonably big. But there you go. Okay. So a slightly more complicated example of a combustion, but the same principle still goes. If you end up with a fraction, you can work with it as long as it doesn't show up in your final answer. Moving on, and before I get started on this one, if you like what I'm doing, then please like and subscribe and leave a comment in the discussion afterwards. So, metal in concentrated acid, specifically concentrated acid, for the simple reason that if you try this in dilute acid, it simply wouldn't work. Okay. We have copper. Now, copper nitrate is the most complicated thing. So that's probably going to be a low number, but let's see where we end up. We have Cu, we have H. We do need the nitrogen and the oxygen separately here because some of the nitrate is being broken down. Okay. So to start with, we have one of each. We have one H, but we have two from the H2Os. We have one N, and here I already have three N's. And then we have three oxygens, and on the right I count a grand total of 8 for now. So that's the starting point. Now, if I only take two HNO3 to form my copper nitrate, I'm not going to have enough to make everything else. So I'm going to need at least probably 4. And we can see how we end up with that. This should be a 2, right? No, because then you still end up in trouble. So we start with a 1 here. So if I have 4 HNO3s, then this becomes a 4, this becomes a 4, and this becomes a 12, right? But if I have 4 HNO3s, I must therefore have 2 NOs because the other 2 nitrogens have already been used. So this should be a 2. And I have 4 hydrogens now. So that should get me 2 H2O, right? So now the last thing to check are the oxygens. So 1 copper nitrate means that I have 6 oxygens there, plus 2 from the NO gets me to 8, plus 2 from the H2O gets me to 10. So there are 2 more oxygens that I haven't used yet. Now the easiest thing to do with those is to make water out of them. But 2 more oxygens to make water means that I need an extra 4 hydrogens. So that should mean that this goes up to 8, right? Gets me 4 extra hydrogens. But if that goes up to 8, then how many copper nitrates? I can't use anything else. So let's try to put this to 3. So we use all those nitrates for that one, okay? That should mean that my NO stays the same. And my water now goes up to 4 because I've got 4 extra hydrogens. So for those 2 extra oxygens, let's see where we end up. So my hydrogen went up to 8. My copper went up to 3, we said. The nitrogen also went up to 8. And the number of oxygens, 8 times 3, gets me a whopping 24 oxygens on this side. So now on the other side, we have 3 coppers. We have how many hydrogens? I have 8 hydrogens here. Nitrogen, I have 3 times 2 gets me 6, 7, 8. And finally, for the oxygens, we have 2 times 3 times 3. So 2 times 3 is 6 times 3 is 18, 19, 20 with the nitrogen ones. and another 4 from the water gets me to 24, and we are done. Okay, so a bit more complicated, but you can still get there with the same method. So count your atoms, consider what kind of ratios you need, and step by step work your way through it. Okay, last one, another copper one. This one is a decomposition reaction, because we started off with copper nitrate or copper 2 nitrate properly, and we make copper 2 oxide. It's that black stuff, the very fine powder, and we also make NO2 gas and oxygen gas. Okay, so let's take a look here. We start off with 1 copper. On the left, we start off with 2 nitrogens and 6 oxygens, and on the right now we have 1 copper, and we have how many nitrogens? 1 nitrogen, and we have 1, 2, 3, 4, 5 oxygens, so it doesn't quite work. Now, one thing to consider here is that you're going to need an even number of coppers due to the number of CuO formed. That's the way it works out, because otherwise they just don't add up. So I can start right away by trying this with 2 CuNO3s. So if I have 2 CuNO3s, then I should have 2 CuOs, right? 2 copper nitrates means I have 4 nitrogens, so I should have 4 of these, right? And let's see where we end up with the oxygens then. So this becomes a 2. The nitrogens becomes 2 times 2 gets me 4. And the oxygen, 2 times 3 is 6 times 2 gets me to 12. And then on this side, the copper also goes to 2. The nitrogen now is at 4. And the number of oxygens is going to be the tricky bit. So this is why I wanted an even number of CuO, because otherwise you're not going to end up matching it up to your copper nitrate oxygens, because they're going to be an even number. So 2 CuO, so that's 2 O's, 4 NO2, so that's 8 O's, so that's 10 total. I need to get to 12, so if I put a 1 here, I end up with 12 oxygens, and that's the job done. Okay? So, step by step, working your way through it, thinking about what kind of ratios you need where, and you get better at that the more you practice, like with everything. Okay? And then we can get to where we need to go with it. Now, oops. For the trickier ones, there is also a mathematical approach to solving this, which ends up setting up equations with multiple unknowns and all that kind of fun. I have not had the need for it. Okay, it does exist. You can find more information about it. Try LibreChem, for instance. There are options. I'll put a link in the description for it, but you generally don't need it. Okay. Best way forward, as I said, practice, practice, practice. Okay. I have no specific question for you for this part right now. It would simply be how do you get better at this? You do it, and you do it repeatedly, and you do it throughout the year, because it comes back in all other topics. Okay, so that's it for this time. Thank you for watching. Final question, as I said, is really a statement, not a question. Practice, practice, practice. Like, subscribe, and leave a comment if you liked it. Thank you very much.